Okay, so I just want to make a video about how to do standard normal calculations using a z-table and using your TI-83. So first of all, let's just assume that we've got a normal distribution of, say, IQ scores. And let's say I know that the IQ scores are normally distributed with a mean of, let's go 100 and a standard deviation of 15. And let's say that you took an IQ test and you found that your IQ test was equal to, let's say you're significantly above average and you found an IQ of 120. So I want to find out what percentile ranking that puts your score. So in order to do that, let's turn this into a z-score. Remember, a z-score is just how many standard deviations either above or below average you are. So I'm going to go, our z-score is, let's see, it's xi minus mu divided by sigma. So in this case, it's going to be 120 minus the mean, which is 100, divided by the standard deviation, which is 15. So I get, what, 20 over 15, which is, what is that, 4/3, so that's 1.33. So you're 1.33 standard deviations above average, right? So 20 over 15. So now what? So I know that I'm looking at a normal distribution, right? So if it's normally distributed with a mean is 100, standard deviation is 15. Remember, the first inflection point is where the first standard deviation goes. So this would be 115. So you're out here someplace at around 120. So clearly you're, well above the 50th percentile, and in fact well above the 84th percentile. So my guess is that you're roughly the 90th percentile, but how can we know for sure? So we're going to go to the z-table, and we're going to find 1.33 standard deviations. So notice these are negative z-scores. We want positive z-scores. So you are 1.3, and then across the top is the second decimal place. So 1.33 standard deviations. So right there, my guess was pretty good, 0.9082, which means that this area under the curve from 120 down to negative infinity, this area is 0.9082, or approximately 91%. So that means you are basically, roughly, at the 91st percentile. So that means 91% of the people did 120 or below, and 9% of the people did better than you. So how can I do that same idea on a calculator? So in order to do it on the calculator, you have to find the normal CDF command. So that's in the distribution key. So we're going to go second function distribution, go down to normal CDF, and we're going to enter everything in terms of z-scores. I don't have to, but it's just a habit. So what do I know? I'm looking for your percentile ranking, right? So percentile means at or below you. So the lower limit, therefore, would be all the way down here at negative infinity. So the calculator just enters -1 times 10 to the -99th. I don't need to be that far down. I'll just go like -1,000. Up to, well, what z-score was it? It was 1.33. Whoops, 1.33. Leave the mean and the standard deviation as 0 as 1. As long as you're entering these values in terms of z-scores, leave it as a 0 and a 1, and paste it. And I get the same answer I got before, right? 0.9082, 0.9082. Now, with the calculator, you can also enter it in raw scores. So I could say, well, the smallest IQ score would be 0. We're going up to 120 with a mean of 100 and a standard deviation of 15 points. I can do it that way as well, and I get 0.9087, not exactly the same thing, because I've left off some of this left tail down here. So it's close enough, right? 91% is what you'd round that to if you're rounding it to the percentages. But you can enter the scores using the raw values, or you can enter the scores using the z-scores. I prefer entering everything in terms of z-scores. So I could do additional questions. So like if I asked you, where's my eraser? You would go, I don't know where your eraser is, Swicker, because I'm not in the room with you. All right. So let's do the same type of problem and say, All right, I want to figure out what percent of the people have IQ scores between 90 and 110. So I know I'm looking at a distribution where the center is at 100, right? Because we're using the same mu equals 100 and sigma equals 15. And I want to know what percent of people are, you know, in this center of the distribution between a slightly below average and a slightly above average IQ, from 90 to 110. So again, I'm going to just find the area in between these two values. And I'm going to do it two ways. I'm going to do it on the table, and I'm going to do it using the calculator. So I'm going to need the z-scores. So the z-score for 90 minus 100 divided by 15. So this is negative 10 over 15, which is what? Negative 2/3. So that's negative 0.67. All right, so that means the z-score for 110 is going to be positive 2/3, which is positive 0.67. So now, if I only have the table, then I'm going to have to do a little bit of arithmetic here. So 0.67, that has a percentile ranking of 74.86%. So I know that on my curve, from this z-score of 0.67, this area down here is, what did I say, 0.74, I forgot, 0.7486? Yeah, 0.7486. But that's the percentile ranking for this 0.67, or for the 110, right? So I now need the negative 0.67. That has a percentile ranking of 25.14%, so 0.2514. So this area down here is 0.2514. So I need the area in between there. So I'm just going to take the large one and subtract out the small one, and then that'll get me this region inside. So I'll take 0.7486 and subtract 0.2514, and what do I get? 2794. 0.4972. Did I do that right? Let's check. My arithmetic sometimes is bad. 0.7486 minus 0.2514, and I get 0.4972. So therefore, that's right around 50% of the people, right? 49.72% of the people are going to be from an IQ of 90 to an IQ of 110. Okay, can I do that same thing on the calculator? Of course we can. We can do distribution, normal CDF, and the lower bound would be 0.67, and the upper bound would be, negative 0.67, and the upper bound would be positive 0.67. The mean is 0, and the standard deviation is 1. Remember, we would use the normalized scores, so the mean and the standard deviation would be 0 and 1, since those are in terms of z-scores. And paste it in, and 0.497, right? Basically the same answer I got there. And again, I could also go from an IQ of 90 to an IQ of 110 with a mean of 100 and a standard deviation of 15. And again, I'm going to get, now notice it's slightly different, right? Because that negative 0.67 was actually a rounded z-score. So that's why I don't have exactly the same answer, but it's close. So 49.5%. Okay, I hope that helps.